Hello, my name's Tate, and welcome to my Emacspeak C tutorial. I think that's what I'm going to call it. I'm just going to start really simple here. I'm going to assume that you already have Emacspeak installed. There's plenty of guides online on how to do that. If you're using an Arch-based Linux, so Arch, Artix, Manjaro, those family of Linuxes, you can download it through the AUR. And I believe Debian and Ubuntu and Kali and all those ones, they have it through the main repository. So you can just apt install Emacspeak. Assuming you're familiar with the Linux environment and all that is simply a given in this video. I'm not going to try to help with, Windows and Mac problems, although the Mac problems tend to be very similar. It's just too much work. So this is targeted towards people who already have Linux running and who want to learn a little bit more about Emacspeak and also about C. So Emacspeak is this cool extension for Emacs, or maybe a subsystem for Emacs, and it just adds speech. So instead of having Emacs and just having it plain and needing to look at the letters, if someone is blind or can't see very well, they can just use the speech to interact with their computer. So I'm going to fire up Emacspeak right now. Those of you who can see, you'll be able to see it on my screen. Those of you who can't, all the output will be recorded as well. So let's get that going.
eSpeak 1.50 eSpeak.
So it runs eSpeak, which is the speech synthesizer. You can run other ones, but I've never been able to get them to work. The most annoying part about Emacspeak when you first run it is how slow the text is. I'm going to read the first line in the default buffer of Emacs using Control-E-L. Control-E-L will read the current line to you. So let's try that.
Welcome to GNU Emacs, one component of the GNU/Linux operating system.
Pretty slow. You'll also notice that it verbalizes the commas and the periods. This is because it's meant for programming mostly. You can change the punctuation mode if you want. But because it's mainly aimed at programmers, because it's mainly aimed at programmers, it's going to tell you everything that's on the screen. It's not going to miss anything. So the most annoying part is that it's slow. Well, let's make it faster. That is Control-E-D-R.
Enter new rate, :
Okay, so that is Control-E, then you let go of Control and E and hit D and hit R. So now enter new rate. So let's do 250.
250, set speech rate to 250 locally.
It's a little bit faster. We'll read the top line again.
Welcome to GNU Emacs, one component of the GNU/Linux operating system.
So that's okay. I can make it faster. I don't know about everyone else. I can understand about 350, but I understand that not everyone can, and this is aimed at semi-beginners. And I know even people who use a lot of screen readers, they're not used to this voice, and so I've decided to be a little bit on the lower end. Anyway, today we're just gonna go over printing stuff in C. That simple, no more, no less. Make it easy. That's the first step, really, in anything else. Anything else you can do, displaying graphics, choose your own adventure games, if you want to connect to the internet. Really, all of that in C tends to start with the concepts that you learn from being able to print stuff. So we're going to start there. To open up a file, it's Control-X, Control-F.
Find file, : document /described -tutorials /c /printing /.
So you'll notice that I'm already in a directory. I'm in my documents directory under described tutorials, then C, then printing. And I'm going to open printing.c. Now, I can actually list my files. So if I hit tab,
find file, : document /described -tutorials /c /printing make file printing.c printing.c tilde.
So you'll notice that it verbalizes that first letter in the file name. You'll notice that it also gives you ... and /. That's kind of annoying, but can't do anything about it. And I'm going to open
printing
printing.
dot C. Printing dot C. C slash asterisk L. Top.
Okay, so now I have my C file open. Now, this is an empty file right now. There's nothing in here. So I'm just going to leave a comment for now to say
will be print.
I'm going to turn off character echo.
Turn off Emacspeak character echo locally.
So to do that, that is Control E, D, K, and that will turn off character echo.
Space printing stuff here.
Okay. So when you select over a new line, it will describe the entire line to you. So if I hit my up arrow,
we will be printing stuff here.
We will be printing stuff here. Okay. So now what we're going to do is we're going to split our window. So to split your window, you can use Control X3. Control X.
Printing.C2, C/*L, bottom.
So now I have two windows which have the same thing open. Well, let's change that. Using M-X, or rather Alt-X is the default configuration.
M-X.
We can type a command to run in the other window. So right now we are going to open a shell.
SHELL /document/describe-tutorials/C/printing/auto-speak 2.
So we've started a new shell and we can input commands here. That little click, that's the sound of the program returning. So you will get that anytime a program is run successfully. If we want to see what files are in here, we can do something like ls-1.
ls-1 make file printing.c tilde.
Sometimes it's kind of hard to tell the difference if you do just plain ls, because it likes to put them on one line when it can.
Make file printing.c tilde.
So this way, if you do ls-1, this will put everything on a separate line, and then you can use your arrow keys to go up and down.
Make file printing.c tilde.
So if I use my arrow keys here, I can actually go up in the buffer.
Printing.c tilde. Printing.c. Printing. Make file.
No problem.
$ls-1.
You'll notice that there's a $sign before any command we run. That $sign is to indicate that it's a command prompt and not just some random line of text.
Printing, end of buffer.
It'll give me a warning when it's at the end of the buffer. To go between my two windows, so now I have my shell and I have my file. To go between them, it is Control X-O.
Printing.c2,
You'll notice it gives a kind of, I don't know, I want to say a sword, the sound of a sword hitting metal. I'm not sure where they got that, but
/document/describe-tutorials printing.c2.
You'll also notice that You'll also notice that the sound changes depending on which window you're moving to. I believe they have a few of them. So you might be able to, like, if you have 5 or 6 windows, it might give you a different sound each time. Not 100% sure. I've never had more than 2 windows open, really. So now we're going to start printing in C. Now the important thing to know about C is that it's a compiled language. Basically, it means that the computer does not understand it, and it needs to be saved into an intermediate language so that, intermediate language isn't the right words. It needs to be translated into computer code. It needs to be translated into the ones and zeros the computers understand. So let's start with the most basic thing, which is a compiler. So a C compiler takes our C code that we're going to write by the end of this video, and it turns it into a runnable file, a file which the computer can understand. So let's start programming a little bit of C. The first thing we're going to do is we're going to create something called our main function. This is always what runs first in a C program. Main is the name of the thing which is automatically run every single time. And to start our main function, we do int main. Then, then we do open parenthesis, close parenthesis.
Cap matches int main left paren.
You'll notice that whenever we have a closing parenthesis,
main left paren. Cap end of buffer.
Quiet. You'll notice that when we have a matching parenthesis, it will let us know that it's matching and where it is matching from. This is very helpful when you're programming because sometimes you'll forget a brace or a parenthesis or a square bracket or anything like that, and it becomes very annoying. So now we will open int main with a squiggly brace. I believe they call it a left brace. What do they call this?
Left brace.
Yeah, left brace. Okay, so if I read this line, it will be
int main left paren right paren left brace.
And that basically says we are starting main. Don't worry about the int yet. We'll get there.
Cap matches int main left paren right paren left brace.
So now we have our right brace on line.
C-E.
Oops.
Cap line 4.
There we go. So we have our right brace on line 4, and we have our int main
left paren right paren cap line 3
on line 3. Now line 3 and line 4, you can get this information by doing Control E, Control L. So notice before I said Control E, L will tell you what's on a line, and Control E, Control L will actually tell you which line you are on. So now what we're going to do is we're going to add a new line in between these two braces.
Right brace, right brace.
Okay, so now we have line 3.
Int main left paren right paren left brace cap line 3. Right brace cap line 5.
And line 5, which is our closing brace. That hissing noise means I used a tab character. That means that I've indented my code. Technically, this isn't necessary, but it's nice for people who can see to be able to use the indentation to look at, okay, where does a function start and stop? It's pretty useful. You'll see why later as we nest things together. So the most simple C program we can make just prints something to the screen. So let's print something to the screen. We do this with printf, P-R-I-N-T-F. Then we use an opening parenthesis and then double quotes. Double quotes indicate a raw text string, a raw piece of text in C. It says, this is a string. Treat it as text. Do not treat it as code. I need to do something with this text directly. The classic example is always to print hello world. So we're going to print that.
Hello
world. And then we will close it with right parenthesis.
Matches print left paren.
And then we will close the entire line. Okay, Emacs, it's okay. And we will close it entirely with a semicolon.
Invent to print left paren quotes cap hello comma world exclamation quotes right paren semicolon.
You'll notice that when you hit semicolon, it will read the entire line back to you. That's by design because you need a semicolon to terminate a statement, which is basically the smallest unit of measurement in C. It is, this is one line, this is one thing I want to do this thing. So when we hit semicolon, it says, okay, this is one instruction. We're going to pass that off to the compiler to turn into machine code, which is the ones and zeros that the computer understands. Now, finally, on our last line, we're actually going to put return 0. So before our right brace, we are going to put return
Y. Return. Invent to return 0 semicolon.
Return 0. Now, returning 0 says this program ran successfully. So we just want to make sure that it knows. So that's it, really. There's only one thing left to do. If we save this file, which you can do with Control X, Control S.
Saving file /home /state / document /described -tutorials /c/printing.co3.
If we save that file and we switch back to our shell, remember that's Control X O.
~document /described -tutorials /c/printing ** autospeak 2.
Okay, so now we're here. And let's make this file. So I've included a make file by default. You'll need the Clang compiler, C-L-A-N-G. That compiler has clearer error messages if you're just starting out. So on Linux, you can install Clang. I'm pretty sure Clang is in every distribution's default repository, so you won't have to go looking anywhere for it. So let's make this program.
MKE. Clang explicitly provide a declaration for quote print quote one warning generated dot.
Okay, so it says implicitly declaring library function. Hold on, I'll where's the? Here we go.
One warning explicit left rack printing clang -o printing.c.
Okay, so that's the output from make. So if we go up one more, you'll see that we ran make. And then the first line of output is clang -o
printing.c.
printing.c. So that just makes, it takes printing.c and it turns it into binary code that the computer understands. It says printing, well, I'll let it read itself.
Printing.c :4:3 warning : implicitly declaring library. Function print with type. Int left parent const char asterisk comma or 3 dot right parent left bracket - implicit - function - declaration right bracket. Print left parent quotes hello comma world exclamation circumflex.
Okay, so the circumflex is really seen as kind of like an arrow, because it looks like a pointy hat, and it's just pointing to printf.
Print left parent quotes hello circumflex.
And it's saying, hey, there's something wrong. This shouldn't be happening. Implicitly declaring library function, which is the first part of that error. That basically means it doesn't know what to do, right? We were running printf, but the compiler is confused. Why is it confused? Well, let's find out. In the second part of the error,
printing.c :4:3 note includes the header less than stdio.h greater than or explicitly provide a declaration for quote print quote one warning generated $.
So that second part of the error says, note, include the header stdio.h or explicitly provide a declaration for printf. So we forgot our header. This is the most important header you will ever use when working with C code, is stdio.h. It is used in almost every C program I've ever seen. So let's switch back to our file.
Printing.c to c/*l 97%.
Remember that is Control-X-O. And we'll go up a few lines.
Indent to print left parent int main left parent.
Okay, we have a blank line here. And in this blank line, we are going to put pound include less than stdio.h greater than. What these do, what this less than and greater than do, is it tells the compiler, look in my system, it will be somewhere, just trust me. This is usually what you want. We'll talk later about how if you have a lot of code, it makes sense to kind of split it into little files. And those can be included with quotes instead of less than and more than signs. Anyway, we'll get to that eventually. So, okay, this looks good. Let's read the line.
Pound include less than stdio.h greater than.
Okay, it doesn't pronounce it correctly, but I can't expect it to. And then we will save it with Control-S, Control-X, Control-S.
Cap, saving file /home/text/ cap, document /described -tutorials /c/printing.c or 3 dot.
Okay, perfect. And now we can hit Control-X-O again to get back to our shell.
~document /described -a ke.
And now we can run make again.
Clang -o printing.c.
You'll notice that we didn't get any information back. There was no errors, nothing. In Linux, this tends to be the case. If there's no output or minimal output, that is good because it means nothing went wrong. So now we should have, if we do ls-1,
make file printing.c tilde.
Printing.c tilde, by the way, is just a temporary file that Emacs makes while you're editing it. It will disappear once you close your editor. So now we have something called printing. So to run this printing file, we're going to run /bi printing. You'll notice that there's a little mouse squeak is the best way I can put it. That is autocomplete. So if I have part of my word complete and I hit tab, it will try to autocomplete it for me. And when it does, it will say the rest of what it autocompleted and make that little mouse sound to let you know that it worked. Okay, so we're going to run printing and hit enter. Now you'll notice it didn't make any sound. Why didn't it make any sound? Those of you who can see will notice that it actually printed, it actually printed hello world. Well, why did this happen? It turns out that if you're in a shell, you need to have a new line at the end, otherwise Emacspeak will not read it. So very important to add a new line. Well, how do we do that? Well, let's switch back to our file.
Printing.c to c/*l 48%.
Okay, and we're going to find where we had printf. This is a very useful function in Emacs if you don't want to like go up and down your file. Oh, what do we have?
We will be pound include less than stdio.
It's not that one.
Main left
it's not that one. You can just hit Control S
search colon.
And it opens iSearch. So this will search forward in your file and look for a reference to something. So let's say printf.
Print cap mark saved where search started.
Okay, so it'll say that. That means that it took you somewhere, and you can hit Control EL, and that will read the line to you.
Invent to print left paren quotes cap hello comma world exclamation quotes right paren semicolon.
Okay, so we're on that line, perfect. And let's add a new line character. The new line character is represented with \n. You can't really type a new line character, so this is what they settled on. So let's go to the end of that word.
Quotes AELLO comma space WORLD exclamation quotes.
Okay, and then we will add \n. So now we'll read the line again.
Invent to print left paren quotes cap hello comma world exclamation \n quotes right paren semicolon.
Okay, and now we have written a \. If you're wondering, how do I print a \? It's \\. That's a fun fact for you. So now we're going to save it again.
Saving file /home /text / document /described _tutorials /c /printing /
That's enough. Now we are going to compile it again. So one thing to remember about C programs is now you've changed the code, you've changed the human readable version of it, but the version of it that the computer understands was compiled from an old version. So we have to recompile every time we make a change. So let's run make.
printing.c.
Okay, and now we will run /printing.
Left bracket left bracket printing hello comma world exclamation $.
Look at that. That $, again, is just letting us know that we're in a command prompt. But now, yes, indeed, we do get hello world. One other thing is you can stop Emacspeak from talking with Control ES. Control ES will stop it from speaking. So if it's trying to say something long, like for example, if I switch back to my file, listen to this.
Printing.c to C/*L 84%.
Okay, that's not too much information. But let's say we save it. Oh, well now it's going to print the whole path. Oh, there's no changes.
Right semi. Saving file /home /text document /described _tutorials.
So I hit Control ES and it will stop that output.
Space new line. Saving file /home /text.
And there we go. I can just shut it up anytime. So that's the basics. Also, Emacspeak should have a sound when I'm hitting backspace, but you'll notice that it actually
print left paren quotes cap hello.
It actually doesn't make a sound when I'm hitting the backspace. That should be fixed soon. I'm not sure what's going on. So it'll be a little bit more clear what I'm doing. Anyway, there's the start of C programming with Emacspeak, sort of a workflow tutorial along with C. But we'll actually like do stuff in the next tutorial once we're a little bit more familiar with these combos. Okay, that's it. Bye.